So today we are going to go ahead and do this example using the growing perpetuities equation. The growing perpetuities equation says that the present value of the perpetuity is equal to the amount of cash flow over the interest rate per period minus the growth rate per period. So here's an example. An investment offers an indefinite cash flow of $2,500 per year that will increase by 5% each year. The return of investment is 10% annually. What is the value of the investment? Okay, so for this one, first we need to identify A, which is the cash flow. So the first cash flow is going to be $2,500. Then we have the growth rate. So it says that it'll increase by 5% each year. So therefore, the growth rate is 5%. I'm going to write the decimal form of that, 0.05. And then the investment rate per period is going to be 10% or 0.10. And notice that it's 5% each year, and also the return on investment is 10% each year or 10% annually. So those do line up. If those didn't line up, we would have to rearrange one of them in order, like we'd have to convert one of them in order to get them to line up before we put them into the present value equation. Otherwise, we'll get something inaccurate. So therefore, the present value is equal to $2,500 over 0.1 minus 0.05. So that is going to be equal to 2,500 minus 0 or divide by 0.05, which is equal to 50,000. So essentially, this perpetuity today is worth $50,000, and based on these requirements, based on these things, we know that $50,000 indefinitely produces $2,500 each and every year, which is pretty cool. That's why money works for you. Well, as long as you have it, as long as you're not the one owing it. But anyways, that's it for this one, and we'll see you for the next one.